Hi, I'm James with Epilog Laser. Thanks for joining us for our masterclass on industrial part marking. Whether you're new to laser technology or looking to refine your processes, you're in the right place. Now, Epilog Laser was founded in 1988 with the vision of bringing the latest technology in laser engravers and cutters to businesses of all sizes. I've personally been with Epilog for close to 25 years now, and in that time, I've learned many tips, tricks, and techniques to help you learn how to be successful with your laser. In today's masterclass, we're going to be going through some of the fundamentals of part marking, looking at some best practices, and teach you how to get the most out of your laser system. So today we're going to cover a number of different topics, starting out with the fundamentals of fiber engraving for any kind of industrial part marking. This is going to include the number of different marks that you can get with a fiber laser system. We'll show a project on our flatbed system as well as on our Galvo laser system where we get different marks using these settings. We'll talk about dialing in your settings so you get the perfect mark on any material, jig and template creation, as well as prepping your materials before you engrave, material settings, and choosing the right laser technology for your application. Let's get started. So we're going to start out by taking a look at some of the fundamentals of industrial part marking. This really comes down to what your goal is with your mark, and that's usually to get a highly readable, clear, consistent mark that's going to hold up to whatever conditions that part or tool is going to be exposed to. And that can really differ a lot from part to part. So the type of mark that you're going to do and try to get with the laser is really going to be dependent upon those conditions. So you're going to be hearing a number of different terms today for different types of marks that you can achieve with the laser. These include engraving, surface marking, annealing, and even a polished or a frosted look of a mark. And these really refer to differences in the depth of the mark, as well as the durability and the color of the mark. Now, the first mark we're going to take a look at is an engraved mark. And this is where we're actually ablating the material to get depth into the metal. Now, some of the pros of this are that it's a permanent mark and resistant to wear and abrasion. It also works well with a wide variety of metals, so you can use it on almost any metal to get a nice mark. The depth that you want to get into the metal can be controlled through settings. So if I want to get a lot of depth, I can actually do multiple passes and get a really nice deep mark. It's also good for harsh industrial environments because you are getting depth into that metal. Some of the cons are if you're trying to get a lot of depth, it's a slower process because you are doing multiple runs on it to get to that depth. Since you are removing actual material, it's changing that part dimension a little bit. So it depends on what kind of requirements you have for keeping that metal intact. When you're getting depth, you can also create stress or warping of the metal if it's depends on the thickness of the metal that you're engraving. And because you're getting depth, you can trap dirt or contaminants within the metal itself. So the next mark we'll take a look at is a polished or a frosted mark. This is going to be that bright white mark you sometimes see etched into metal. And this is an actual etching. We are going lightly into the metal. And one of the biggest pros of this kind of mark is it's very fast, so you can move quickly between your products and engrave just in a few seconds. The look is very visually appealing. It gets that nice matte frosted look. And that looks especially good on a polished or reflective surface where that mark really stands out. Now, there's a few cons to this. It's less durable than etching because you're not going as deep into it. And sometimes it depends on the metal. Small fonts can be a little less readable with this kind of white mark. Now you are going into the surface a little bit, so there is a little bit of surface roughness, so it's not suitable for all precision parts if that's a requirement of the engraving that you're doing. Now the third kind of mark we're going to take a look at is an annealed mark. And this is where you're actually getting a color change on top of the metal. What we're doing is we're superheating that metal so that it actually creates oxidization on the metal itself, creating that color differentiation. Now, the result's usually black, but you can also get other colors by adjusting your speed, power, frequency, and focus. Now, one of the biggest positives to this is that there's no material removal. So you're actually maintaining your surface integrity, and it's really ideal for applications where that's very important. It's also very corrosion resistant. There's no exposed raw metal, so it retains its protective coatings. You also get a really nice color variation. You can produce blues and blacks and other hues kind of depending on your material and your settings once you get those dialed in. Some of the cons are that it is a slower process. We're running the laser at a relatively slow speed to get that nice black mark. It's limited on the metals you can actually engrave, so you can use it mostly on stainless steel and titanium to get a really nice result. And it can be a lower contrast, in especially low light or on dark surfaces, it can be harder to see that black mark. So the type of mark that you want on the fiber laser is really dependent upon your material, as well as what kind of conditions that material is going to be used in. Now, we'll be showing you a number of different marks like this and how to achieve these marks as we move through this class. So we're going to start out by taking a look at the software we're going to be using today. Now, one of the nice things about Epilog's laser systems is that they're open architecture as far as you can use whatever graphic software you're most comfortable with. So today we're going to be using CorelDRAW right quite a bit, but you can also use Bartender, AutoCAD, Illustrator. It's really up to you. If you can print from the software, you can send it to the laser. Now, whenever you print from that software, you're going to be printing it into our laser dashboard. You can see here a graphic that we've brought in here. And over here, you're going to see your processes. So you can set up all of your settings right on the screen here. So we're doing 2 hatch patterns. In fact, if I wanted to, I could even come in, click this down arrow and do a hatch angle array where I could set up, let's say, 4 hatch patterns, changing them by 45 degrees each. Click save, and it's just going to automatically add all of those hatch patterns to it. So it's very easy to use. And as you can see, you've got your camera here, so you can use that to align your graphic as well. So as I said before, we're going to be using CorelDRAW quite a bit today, but it's really up to you. So next up, we're going to be taking a look at using our flatbed fiber system to be able to create multiple marks on a large work area. Um, as you can see here, we've got a jig that we've already cut out, and we've placed our 3 logos. So let's go ahead and select those. And we'll just print those over to the laser. So once these come in, you can already see one of the big benefits of the flatbed system, and that's the large work area that you have. Here we've got the Fusion Edge standalone fiber laser. So it's a fiber laser only in this machine. It's a 30-watt MOPA, and it has a 24 by 12 inch table. We also have some dual sources, Fusion Pro systems up to 48 by 36 inches that can also accommodate the CO2 laser as well as a fiber laser. So several different options for if you're looking for a flatbed fiber solution. And the reason people like a flatbed fiber is basically because they can do multiple parts, walk away while it's engraving, come back and have them all finished up. So you can see here that we've got the 3 logos and they're already perfectly positioned because we used that same jig file that we used on the CO2 laser to cut it out. So I'm just going to go ahead and ungroup these. Now I can just select the second one. And up here, I'm going to click this plus selection. You can see it created a separate process for that one. Now I'll do the same thing for this third one. So the reason we're doing this is I want to kind of talk about the different marks you can get with a flatbed fiber system. So let's go ahead and select this top process, and that's going to be our graphic on the left. And we'll import some settings here. And I'm going to come down to steel because we're doing this on a 304 stainless steel. And I'll choose an etch mark. So with the etch mark, we're actually trying to get some depth into the metal. When you're going for that kind of mark, what we're going to do is first of all set our resolution. And this is going to be basically the dots per inch, which is also our line spacing. So on a deep engraving, I wanted about 500 DPI. Speed, we're going to slow down so we get that depth in there. And we're going to turn that down to 20%. I'm going to take my power all the way up to 100%. So now for frequency, we've got that all the way down to 1%. Now, when we're saying low frequency, that is the number of pulses that are happening per second. There's fewer pulses, but there's more energy per pulse. So that more energy can blast away or ablate the more material each time the laser fires. Now for waveform, we've got this all the way up to 15. And the reason we have it all the way up there is it's a long pulse duration. So it actually pulses longer, so you have more heat applied to the material and you can remove more material. So I'll go ahead and do this one bottom up engraving, and we're all set for our etch mark. So moving on to the second process, which is going to be the center gear, what we want here is a white mark on it. So I'm looking for that frosted or polished mark. So I'll go ahead and import in my polish settings. And you can see here that we're going to use a resolution a little bit higher than we did on that etch. So I'm going to take this up to 600 dots per inch. So that line density is a little closer together. Speed, I want a lot of speed, so I'm just going to go all the way up to 100%. Power, about 20%, so pretty low power on a 30 watt. And then frequency, we're going to put it about 5%. Now, like I said before, if you have a 1% frequency, you're basically ablating the material. We want to have a little bit less ablation. We want to go a little bit into the material, so I'm just going to bring this up to 5%. And we'll be talking more about frequency and waveform in a bit. And then waveform, I want to have a pretty long duration on each time that the laser pulses. So we're going to take that to 13. So still a little bit lower than what we used to get that etch mark. And I'll set that to bottom up engraving. Let's move on to that third one. That's going to be our gear on the right. And we're going to pull in settings for an annealed mark. Now, an annealed mark is when you superheat that metal, and you actually create an oxide layer on top of the metal. Now, this is very durable, and it's a nice contrasting mark. You can create a nice black mark without actually removing any material. So what we have here for our settings is I'm going to use a pretty high resolution. I want my line density to be close together, so I'm doing that at 600 dots per inch. For speed, I'm going to slow that way down. So I brought it all the way down to 6%. Power, I'm going to go pretty high on. Not all the way up to 100%, but around 70% on a 30 watt. Frequency, now I want to have, I'm not trying to go deep into the metal, but between my frequency and wave, a nice balance is about 20% on the frequency, and then a wave that's a little over the middle point. So we're going to have that about 12. And then the other thing we're going to do is we're going to offset this. So we've set this to 60 thousandths offset positive. So that's going to lower the table by 60 thou. And it just broadens that beam a little bit and gives you that nice annealed mark. So I'll put that bottom top. Let's go ahead and print that over to the laser and see how it comes out. So now we'll go ahead and start the job, and it'll move through each mark individually. First one it's going to do is that deep engraving, and we're going to do 8 passes here, and you can adjust the number of passes based on how deep you want this mark to go. So now it's doing the polished mark, and this is at actual speed right now. We'll speed it up in a moment, but you're going to start seeing that white mark as we engrave this. It comes out really nicely. And finally, we've got the annealed mark. And when we've slowed this way down to 6% speed, so it's a very slow mark, but you're going to get a really nice black mark out of it. So we'll go ahead and let this speed up and see how it comes out. Now, before we take a close look at those marks that we got, I want to do one more thing. So I'm going to come back up to this first one, and I want to do a before and after of adding a cleanup pass to a deep engraving. So we've done our deep engraving, and I'll show you what the results of that were in just a moment. But before we move anything, I'm going to go ahead and add a process here for our polish settings. So we're going to try to take all that carbon buildup at the bottom of the engraving and clean that up a little bit. So using those same settings, bottom to top, and then I'll turn off the other two processes that we don't need this time. And just print that over to the laser. Now we'll start that cleanup pass, and it's going to move quickly through this. And the reason we're really doing this is it's going to remove any redeposited debris within the metal, and then it also is going to smooth that bottom surface. You're going to get a much more uniform look to it. It's also going to be good if you're going to be post-processing any of your metal with anodization or paint or enamel. It's that smooth bottom really ensures better adhesion and appearance to that whole mark. And you can already see how well this is cleaning up. So now I'm going to give a close-up look at each of these marks, but first I'm going to do a little post-processing on the deep mark. I'm going to use this Milsic gun cleaner oil. I find it works really well for helping to define the mark, clean it out, and it also is supposed to help with corrosion. So we'll just use a medium bristle brush here to clean that out. And you can already see just how nicely this is looking. It gives you a nice black mark on that engraving, and then you can just wipe that off with a lint-free towel. And like I said, you can adjust the depth based on the number of passes you're doing to get to the exact depth that you need. So next we'll take a look at that polished white mark or frosted look, and you can see how nicely it came out. And it's a totally different look than that deep engraving, but it's still a professional look, and it's very quick, a minute 57 seconds to engrave. So it's a big time saver. Next, the annealed mark, and this is going to be kind of your iridescent mark. And you can see it comes out black looking, and you're not actually removing any materials. So if that's important to your application, this is a great mark to use. So you can get a lot of great looking marks with a fiber laser. And this is both our flatbed and our Galvo systems. You can get these different marks. Now it's just a matter of dialing in your speed, your power, your frequency, your focus. But once you have that dialed in, you can get all of these marks very simply. Now, besides the difference in look of the mark, the other important thing is throughput. If you want to get a lot of depth, it's going to take multiple passes. We got a couple thousandths of depth using about 24 minutes of engraving time. Now you compare that to the nice looking annealed mark, and that took about half the time at 11 minutes. Or the polished mark, that white mark, only took 2 minutes. So it's a big difference in time and throughput. So you really need to take this in consideration if you're doing this as a customization service, because the time that you're engraving needs to be figured into your costs and what you charge the customer. So next we'll be moving over to the Fusion Galvo G100, and this is our fiber Galvo laser system. Now, when you're using a Galvo laser system as opposed to a flatbed system, instead of the laser moving back and forth across the bed, it's going to use mirrors above the table to quickly engrave your item. So the next thing we're going to do is we're going to show you how to dial in your material settings. And we're going to be doing this on some brass where I want to get a nice black engraving. So to do this, I'm just going to come over to our job manager. This is Epilog software where we've got all the machines that you can add in for any configurations you have. If you've got the CO2, the fiber, the Galvo, got all your jobs that you've run temporarily, as well as you can create folders to categorize your jobs to pull them up easily. And once you pull that up, you can just go ahead and run it again. You can have all your material settings that you adjust right here, as well as your job settings. So we're going to come over to jobs, and I'm going to come to the temporary, I'm going to actually come to the uncategorized jobs folder, and you'll see a button here called generate. Now, when I click on that, that's going to create for us a grid where we can actually test out different variables to find that perfect setting. So I'm going to go ahead and just make this 5 by 5. And I can choose my two variables here. And we're going to choose power and waveform as the two that we're going to test out here. And power, I'm going to run this from 45 to 85. And one thing I like to do is, since I've got 5, I want to make that evenly distributed. So 45, 55, 65, 75, 85. So it gives me even numbers on my results. And then waveform, I'm going to run this from 9 to 13. Speed, I know I want about 35%. And then frequency, I want that at 1 because I want to ablate that material and get some depth into it. Spacing, I'm going to bring that down to 0.0001. Do that at an angle of 45 degrees, 1 pass. And let's go ahead and click save. Now you can see that came up in my uncategorized jobs. So I can double click on that, and that's going to bring that right into the Galvo. Now I can just resize that so I can test this out. And each color box has a different process here with those settings in it. So we'll go ahead and print that. Let's go over the laser and see how it comes out. So now I'm just going to go ahead and press the trace button, see where that's going to be located, and then I'll start that job up. So now that the job's done, I can just go ahead and clean this off, and I'll just use a toothbrush to do that. So now I can take a look at the results and decide which one meet my needs for both depth of mark as well as darkness. So once I've chosen which one that I like best, I know it's this dark purple here. Just scroll down to that one. You can see that's 35 speed, 75 power, 1 frequency, 13 wave. So I'm going to click on this little up arrow folder here, and this is going to export my material settings so I can use this every time that I want to engrave brass. So I've already created a folder for brass in my job manager, and I'll just call this F254 for which lens I've tested this on, and dark mark brass. Save that. Now, if I come back over to the laser dashboard, I'm going to show you one of the features I really like for setting up a graphic quickly. I'm just come over here. There's a little image with a plus sign, and this is copy background image. So I'm going to click on that. Then I'll go to my design software, whichever one I want to use. And I have a page size set up to the same size as that engraving table, so 6 inches by 6 inches. And I'm just going to paste that right onto there. So now I've got an actual camera view of the item, and it'll let me design this right on top of the item, which is nice. Now, I use this a lot of times if I'm doing especially an odd shaped item that I want to fill with a graphic. This just makes it very simple. But even on a simple item like this, it works very well. So I'm just going to grab my text I want to have on this nameplate, bring that up here, bring it to the front. Now I can just resize that. You can see exactly how it's going to look on there. I can align it with the shape of the piece and be very specific about that. So once I'm happy with that, I'm just going to go ahead and print that. And I'll do that selection only, so we don't get that background image. Now when that comes into the laser dashboard, it's still lined up in that exact position. So we're good to go there. And all I have to do is import my setting. And this is the brass setting we already set up in the last step. So I'll just come down to my brass folder, dark mark, import that. And I can print that over to the laser. So now we can just go ahead and start that up, and it's going to start engraving. Now that that's done, I'm just going to use a soft bristled toothbrush to just clean this off a little bit. You can just see how nice and dark that mark came out, just like we wanted it. So what we're going to be doing next is take a look at how to create a jig for the Galvo laser. Now a jig's really useful if you're doing multiple pieces. We're going to be doing multiple data plates like this. They're little 3-inch by 1.5-inch pieces, and they're just going to fit perfectly on that table, so I can fit 6 altogether. Now a jig's going to allow us to be able to quickly change out these parts. We can have an operator run a section of them, take it out, and put the next grouping in. So it makes it really simple. By using a template, we'll be able to put this together in such a way that it'll be easy to create jigs for future products as well. So in the Galvo laser, you can see that there are a number of screw holes that are evenly placed across the table. And we know the distance between these holes, so we'll be able to easily place our jig using these small screws. Now, these can be placed wherever we want on the table, so we'll figure that out and show you how to design a jig like this one, which we can easily place right at the top and just butt them up to those screws. So to create that jig, what we're going to do is first create a new page, and this is going to be for the jig itself. And we're going to make this, let's say 10 inches by 10 inches, the full cutout size of the jig. And I'm just going to switch this over to millimeters so that we can create our screw holes on the table. So I'm going to create a circle. And those screw holes are each 6 millimeters by 6 millimeters. So I'll go ahead and put that there. Then I'll just center that on the page. So that's going to be the center point that we're working off of here. Now, the size of that screw is also important because we're going to be butting up our piece to the screw, so we need to know the diameter of the screw. And that is going to be 8 inches by, or 8 millimeters by 8 millimeters. So we'll go ahead and set up that outer circle. Go ahead and center that. So now we've got the screw hole and the screw itself. So we'll just go ahead and group that together. So now these are evenly placed across the table, and they are 25 millimeters apart. So I'm going to go ahead and set this to 25 millimeters as my duplicate distance. Duplicate that across. And then I'll do it the other way as well to finish off that row. And then I'll change my Y duplicate distance to the same. Select that whole row, just duplicate that down, change that to a positive number, and we'll duplicate it up. So now we have a really nice representation of the table, which will help us create that jig so we can know exactly which pins we're going to push that up against. So I've actually saved this as this file is Galvo table, so I can use this in the future as well. Now, if I go back to my data plates, I can see that each one's just slightly larger than 3 inches by 1.5 inches. So I've got that at 3.001 and 1.501. So altogether 6.002 by 4.503. So I'm going to go ahead and create a box that same size. 6.001, 4.503. And I'll center that on the table. Now, that same box should be able to hold those 6 pieces together. And sometimes I'll make this box a little bit larger, but it does take a little bit playing around depending on the material. I find that we're going to be cutting this out of a plastic where that kerf of the actual cut hole is going to be enough to make up for any size differentiation. So now that we've got that in place, all I need to do is do my jig cutout. So I'm just going to come up right to here and create a box a little bit larger than that jig size. And I'll go ahead and just line that up with the bottom of those screw holes and these as well. And since we did that outer circle, we know that it'll butt up against those rather than if we had just done the screw hole itself. And the final thing I'm going to do, this is a handy little tool here, I'm going to come in and choose an arrow. Whenever I do a jig, I like to create an arrow on it so that I know what's that top left corner. That just makes it really easy for future placement. So now we're ready to send this over to the laser. Now I'm going to be creating this jig out of plastic, and we'll be doing it out of 2 layers, so the jig actually has a bottom to it, which is going to be helpful for the operator to be able to switch out the parts and have them sit within the jig. They won't have to switch them out within the table itself. They can do it, and as one piece gets done, they're ready to put that next jig in. So I'm just going to go ahead and copy that outer area. So that's going to be our background area. And then I'm just going to select all those areas I want to cut out and print those over to the laser. Now we're going to be doing this on our CO2 laser. CO2 laser is a great thing to have in addition to the fiber laser because you're actually able to cut the plastics, the acrylics, things like that. So we actually have a lot of customers that use both pieces. So I've got a piece of red and white plastic in this table. And it's a 24 by 24 inch table, Fusion Pro 2400 watt. And so now I'm just going to turn off that camera so I can see this a little bit better. And I'll just go ahead and ungroup that. Take this piece. I'm going to move that right up to the top. Copy it and paste it so that I can create 2 jigs. And then I'll do the same thing over on this right side. And that'll be on the white. Once I have all that in, then I just have to import my material settings. And I'm going to be cutting this out of 1/8 inch thick plastic. So let's go ahead and, it's about 1.5 millimeters, so we'll go ahead and select that. So 20% speed, 40% power, 100% frequency. Let's go ahead and print that over the laser and we'll cut that out. So here at the laser, we've got it all set up. We'll just hit go and it'll start cutting. So with the two pieces glued together, I was able to put my data plates right in, slide it up in the corner. Now I'm just going to wipe these off with a little bit of isopropyl alcohol and a lint-free cloth, just to make sure that we've taken off any debris. They did have plastic on there originally. And we're ready to set up our file back at the computer. So now I can just take my data plates and copy them over into my file and just center those on the page. And so now this is set up so I could set these up with variable data and have them come in automatically, and they're going to be perfectly positioned every time. So we'll go ahead and print this, selection only. And we are positioned right on top of the jig, just right where we want them to be. So I can just import my settings. And I'm just going to go ahead and give this anodized aluminum white mark. This is on a 100-watt Galvo G100. So I'm doing 2 passes, 100% speed, 50% power, 1% frequency in a waveform of 10, and doing that at 45 and 90-degree angles. Let's go ahead and print that. We'll see how it comes out. So back at the laser, we'll hit go and start engraving. Now that it's done, we can go ahead and pull that one out. And we'll just take this next one and place it right onto the table. And you can see that it's already been loaded up, so it makes it really easy for the operator to switch out between one and the next, and then they're ready to go ahead and start that next job. So sometimes people ask me about the accuracy of the cameras. This really shows it off here. You're working with such a small work area in the Galvo. Those cameras are very, very accurate. You can see just how right on they are with this small text even. So it's pretty impressive. Now, I use the camera a lot to actually position my artwork, but when you're doing multiple pieces, the jig is definitely the way to go. So jigs are a really important function of throughput on the Galvo laser. Because of your limited work area, it's important to be able to take advantage of that speed of the Galvo laser by being able to set up your table to quickly move between parts. The better your jig set up, the easier it's going to be for your operator to move on to that next part and be ready whenever the Galvo finishes engraving, put that next part in and start it up again. So you can use a variety of different materials to actually create your jig. Now I've used MDF, acrylics, plastics, Delrin, foam. It really depends upon the case situation that I'm trying to engrave. If it's something that I'm only going to engrave a few of, it being able to hold up over time is not as important. If it's something that I expect to be a job that I run again and again, more likely to use an acrylic or something that's really solid. So, a few quick design tips when you're actually creating that jig. The first is material thickness. Make sure that you're choosing a material that's thick enough on that jig to hold that piece stably in place. And like I said before, if you're going to be using this jig over time, make sure you're choosing a material that's durable enough to handle that. Next up is kerf compensation. Anytime you're cutting out a material with the laser, you're actually removing a small amount of material. So you want to make sure you take that into consideration. A lot of times, if I'm using a material, I'll cut a small test piece and I'll use a pair of calipers to see how much material is removed and adjust my design accordingly. The next step to think about is going to be the orientation of the piece in the machine. So make sure that you've indexed it. We've added that small arrow at the top left corner of our jig, and that way our operator knows which way to place the jig when they're putting it in the machine. Also take into consideration, you might want a layered design. In this example, we cut two pieces of plastic and glued them together. The reason we did that is we were able to load the jig outside the laser. If we did not have that back piece, we'd have to place the jig in the laser, put our pieces in, and that's a time consideration for throughput. So next up, we're going to be moving on to some more material settings, but we'll also be using the Galvo laser, and I'll be showing you a trick how you can actually cut your jig in the laser itself. Let's get started. So for this next trick, we're going to be taking a look at how to actually create that jig right in the Galvo laser. We're going to be using a material that you wouldn't typically think of using with a fiber laser, and it's task board. Now this is a matte board product, and it's a nice thin piece. So when you just need a thin material to be able to create your jig, this is a great way to go. So today we're going to be engraving a valve cover breather for a car, and I've got this little cylinder on the bottom that I'm just going to go ahead and measure. I'll just use some calipers, and that's going to come out to 1.024 inches. So I'll start out by just doing that circle here and make that 1.024 by 1.024. Center that on the page. Then I'm going to use that same template we did for the table to create a cutout that's smaller than my 6-inch table. So it's important that you make sure that your piece is smaller than 6 inches. Now I can just line that up quickly with both that top and bottom. And oh, can't forget, I need to add in my arrow so that I know which direction to put it in the laser every time I use it. And that'll just give me a nice registration mark, basically. Go ahead and select that, print it over to the laser dashboard. And now I'm just going to do that with selection only so we don't get that background image, and print. So once that comes into the laser dashboard, all I need to do is import my material settings. And I've already set one up for a vector called task board. What you're going to use on this is very low speed. I've got 1% speed. On the 100 watt, I'm using about 70% power. 60 watt, I used about 100% power. Frequency, you're going to turn all the way up. And your waveform's going to be right around the middle. I found around 6 is a good waveform to use on this one. And print. And we'll go over to the laser. So I'll just use that trace feature, make sure everything's lined up. And now I'll hit go and it'll shut the door and start engraving. And you can see how quickly it goes through this material. It just works really well for creating a really nice quick jig. We have placed a piece of anodized aluminum underneath it just to protect that table from any scorch marks as it cuts through this material. But you know, it just does a really nice job to create these jigs quickly. Now that that's done, I can go ahead and remove it, remove that piece of anodized. Now we'll just set it at the center of the table. And I will put these screws in so I can easily line this up in the future. And the jig will just push right up against these screws because of how we've lined it all up. Now I can take my part, place it right in the center there, and it's lined up and ready to go. So now we're ready to focus the laser. I've got a couple options here. Often what I'll do is I'll use a pair of calipers and measure that piece, and then I can enter that into the display panel. It'll know the correct height. Or I can press the focus button on the display panel, and you're going to see a crosshair here and a dot. And what I want to do is align these two together. So I'm just going to raise that lens assembly until that lines up, and I'm good to go. So we're ready to start engraving that piece now. So what I need to know is the engraving area, and I've already measured that with calipers, and it's 2.350 inches. So I'll go ahead and draw a circle and set that to that size. Now I can go ahead and just center that on the page, and I know that it's going to be lined up with my jig. Now I'm going to go ahead and create an outline inside of there that we're actually going to engrave. So I'll make that a little smaller than my circle. Change that color to black. And give it a width of, let's try 8 points here. That looks good. So I'm ready to bring in my graphic. So we've got the scorpion design we're going to engrave on there. So I can just go ahead and resize that how I want it on the piece. Once that's positioned how I want, then all I need to do is just go ahead and select that and the outline that we're going to engrave and print that. Chosen the Epilog engraver, selection only, so we only got those parts, and print. Now when that comes in, we can see that it's already lined up because we're using that jig file, so we know that we're perfectly positioned. So what I want to do here is I want to get a nice white mark on this. This is a polished aluminum. Frosted or polished engraving comes out really nice on a material like this because you get that bright white look to it. It's very fast to engrave. So I'm just going to go ahead and import my material settings. And I'm using an f254 lens here. And the reason we've using the f254 is it gives us that 6x6 inch work area. Now, we also have an f163 lens that comes with the machine as well. And your difference here is going to be your work area, first of all. So 4 inches by 4 inches for the f163, 6 by 6 for the f254. Now, the benefits of using the F163 are going to be when you've got a smaller spot size and you need to do really, really fine text. For the most part, though, I find that the F254 works really well for most things I'm going to engrave as long as I'm not going to a very, very small font. And it gives me that larger work area. So it's nice to have that 6x6 inch work area. But like I said, both of those lenses are with the fiber Galvo, so you are able to interchange them and use whichever one's best for you. But because of that smaller spot size, there are different material settings based on which lens you're using. So I've got my f254 metal polish. And you can see over here that what we're going to be doing is you're going to be using a relatively high speed. So we're going to 70% speed on the 100 watt. My power, I'm going to go right around 40. So a little below half of its power. Frequency. Now we'll get into frequency and waveform more in a little bit. Frequency is basically going to be how much energy is behind every pulse of the laser. So if we've got a low frequency, you're going to have a lot of energy behind every pulse and you're going to be ablating the material. I want to take that up a little bit for a frosted mark. So I'm going to go up to 10% frequency. And then waveform, which is your pulse duration, is going to be around 5. I want it just below the middle setting. And we're going to do two passes here, one at 45-degree angle and one at 135. And we'll go ahead and print that over. Let's go see how it comes out. So here at the Galvo, we've got this all in here. So all we have to do is go ahead and start the job. So here's our finished engraving, and it came out just beautifully. And it took all of 42 seconds to engrave that. So nice and quick. Got a really great mark on this one. So one of the things that I always do before I start engraving my metal is prep the material first. Now, this is a great best practice whenever you're engraving metal to get a nice consistent mark. And all you need to do is take some isopropyl alcohol and a lint-free cloth and just wipe off that area you're going to engrave. That's going to remove any grease, dusts, or contaminants that are on the metal that could absorb that laser energy and not give you as consistent of a mark. Now, this is particularly important if I'm doing an annealed mark where I'm trying to create that oxide layer. Uh, and if there is any contaminants on there, I might not get the same coloring throughout that engraving. Now, if you're doing a large number, you could put this into an ultrasonic bath where you actually put all your metal pieces in there and use a mild detergent on them. So there's a lot of different ways you could do this, but especially if I'm just doing a one-off part, the isopropyl alcohol is a quick way to go. Now, when you're choosing the laser technology that's going to be best for your application, the first thing I always say is you need to choose your laser source, and that's going to be that fiber or the CO2 laser. Now, for most industrial applications, the fiber laser is probably the way you want to go because you can engrave so many kinds of metal. But for some people, the CO2 laser might be better if they're also looking at doing more versatility in the materials you can work with. While you can't etch directly into metal, you can do coated metals with the CO2 laser, so it is possible to do anodized materials. And you can also use a metal marking spray, which will allow you to get a black, dark mark on metals without a fiber laser. So there's definitely benefits to CO2 laser for some people, depending on their applications. Now, the next thing to look at is flatbed versus Galvo. Now, the flatbed system is going to give you a large working area. You can go all the way up to a 48 by 36-inch piece. So it's really going to allow you to have large pieces you could put onto the table. And you can also create a jig and put multiple pieces across that entire table. If you want to do one piece at a time and have an operator switching them out quickly, the Galvo is great for that. The fast engraving allows you to quickly move between pieces and get a really nice mark on all kinds of different metals. So it's really down to your applications. And if you're looking at getting into a laser, we're happy to help out with that as well. You can go to our website and fill out the form, set up a demonstration, because then you can be hands-on with it. You could even bring your own metals into the demonstration so you can see exactly the marks that you're going to get on that metal with the different technologies. Now, another option is to get a dual source laser system. And these have both a CO2 and a fiber laser available within the same flatbed system. And we've got this available all the way up to a 48 by 36-inch table, and it's going to allow you to have the versatility of both laser technologies So you can engrave everything a CO2 laser can, like acrylics, plastics, wood, marble, glass, all kinds of different materials, as well as having the fiber laser source so you can etch metals directly with all kinds of different marks. Now, this is great if you have especially a small space where you only want to have one laser system that can do everything. Now, your one drawback is that you can only use one laser source at a time. So, if I'm engraving with the CO2 laser and doing jobs with that, I can't run my fiber jobs at the same time. So, it's sometimes better to have the two systems sitting side by side. It really depends on what kind of throughput you're looking for when you're doing your applications. So thanks for joining us today at this webinar, Industrial Part Marking. I hope you found these tips and tricks helpful. Now, there's a lot of different components that go into industrial part marking and fiber engraving. So if there's something else you'd like to learn about, be sure to leave it in our comments so we can do future classes on these subjects as well. If you'd like to find out more about Epilog Laser, visit us at epiloglaser.com, fill out the form, and set up a hands-on demonstration where you can actually try out the laser with your materials, see how it would work for you. Thanks again for joining us, and we'll see you at a future class.